Okay, let's look at section 4.4. This section talks about proofs involving sets. The main technique we use in this section is called the element chasing method. So let's look at that. Right? So let's say we want to establish that set A is a subset of set B. Right? So here how it goes. Just a skeleton of it. Right? So first thing you do is choose any arbitrary element x from A, right? So we pick any element from A. So, and this could be just any element, right? Then you make an argument that x is actually belongs to B as well, right? Since x is any element, so every element in A belongs to B, which means that A is a subset of B, right? That's how we establish the containment. So A is contained in B, right? So let's look at an example here, right? Let's say this is a statement, A intersect B is equal to A if and only if A is a subset of B. Right, so let's try to do that. Right, since this is a if and only if by conditional, we have to write a proof for each direction, each implication. So let's do that. So let's do the implication A intersect B equals A implies that A is a subset of B. Right, so assume, right, assume that A intersect B is equal to A, right? Right, then we want to establish that the A is a subset of B, so we're gonna say choose any element X in A, right? Then since A is the same set as A intersect B, so which means that X is in A intersect B, right? And which implies that right, since x is in the intersection of A and B, which means that x is in both A and B, but the only conclusion we want to make is that the x is in B, so this at least implies that the x is in B, right? Right, therefore we could show that any element x in A also belongs to B, so therefore we know that A is a subset of B, right? So that's the one direction, right? Let's do the other implication. Now we're going to assume that A is a subset of B. So assume that A is a subset of B, right? Then we have to split into two element chasing arguments, because here what the conclusion is an equality between two sets. So we're going to try to show, so first part is going to be, we want to show that A intersect B is a subset of A, right? Right? Then second part is we have to show that A is a subset of A intersect B. Alright, so let's do that. Alright, for this one, we just say choose any element X in A intersect B. All right, by definition of intersection, all right, so X is actually in both A and B, but all we need is X is in A, right? So therefore, so this side is pretty easy. So we could show that any element X in A intersect B is also in A. So we know that A intersect B is a subset of A, right? Let's do the other containment. Let's choose any element X in A, right? Right, but if you know that, let's say A is a subset, since we're assuming that A is a subset of B, so every element in X in A is also in B. So this implies that X is in also B. All right, now we know that the X is in both A and B, so therefore we know that X is in A intersect B, right? Therefore, we know that we could show that all elements in A actually also in A intersect B. So A is a subset of A intersect B, with the assumption that A is a subset of B, right? So combining these two containment, we know that so these two guys combined, we can make this conclusion that A intersect B is actually an identical set as A. All right, so this proves the other implication. All right, so that's the end of the proof. All right, that's it. I hope that this was clear.